One-step equations notes. The learning goal is to solve one-step equations. But first, we're going to cover what is the difference between an expression versus an equation. So an expression is one or more terms separated by math operations. Expressions can be simplified. An example of that is 2x plus 3. An equation is two expressions, and that's the key. There's two expressions set equal to each other. Equations can be simplified and solved. So an expression is simplified. The main difference between an expression and equation is that it can also be solved, and there is an equal sign between two expressions. So expression 1 and expression 2. To solve an equation means to find the value of the variable that makes the equation true, which means finding the value of what is x so that 2 times x plus 3 is equal to 9. So solving one-step equations. To solve a one-step equation means to use one operation to isolate the variable. To isolate the variable, use the inverse operations or opposite operations. So the opposite operation of addition is subtraction. The opposite operation or inverse operation of subtraction is addition. The opposite of multiplication is division, and of division is multiplication. So step 2, equations are like balanced scales. To keep it balanced or equal, you must do the same thing to both sides of the equation. So whatever you do to the left side, and when we say left side, we mean the expression to the left of the equal sign. You have to also do the same operation to the expression on the right side of the equal sign. So step 3, the variable must be positive. So when you're isolating the variable, you want it ultimately to be x equals a number, not negative x equals a number. And step 4, while the variable is frequently isolated on the left side, it can also be isolated on the right side because it might make more sense or there's less operations to do. So let's apply these steps to question number 1. Solve the equations below and show all your work. So question 1, the expression is x plus 5 is equal to negative 2. So our goal here is to find what is the value of x so that that number plus 5 will give us negative 2. And although we can probably do the math in our heads, we'll still follow the steps so that once the numbers do get more complicated, you're able to use a process. So we want to isolate the x. Okay, step 1, isolate the variable. So we have to do the inverse operation to the other terms. So here we have positive 5. I'm going to subtract 5. And if I subtract 5 on the left side, I have to subtract 5 on the right side. So x is left positive 5 minus 5, which was our goal to eliminate the 5. There is nothing left. Therefore, x equals negative 2 minus 5 is negative 7. So let's look at question 2. We have 3 terms here. Term 1, 2, and 3. We want to isolate x, so we're going to do the inverse operation of negative 3 and 4/5 so that the x is isolated. So to do the inverse operation, we have a negative, so we're going to add 3 and 4/5. Whatever we do on the left side of the equal sign, so there's like an imaginary line here, we also have to do on the right side of the equal sign. So plus 3 and 4/5. I'll draw a line. So it is x is equal to, because a negative here plus the same thing, we've eliminated it, is equal to 17 plus 3 4/5 is equal to 20 4/5. 20 4/5. So let's look at question number 3. Our equation has two expressions, expression 1, expression 2. 8x equals 6. So what is the value of x to make this equation true? So here we have multiplication. So 8 and x, there's a multiplication sign. You can also write it as, and I will erase this, as 8 times x is equal to 6. So the opposite operation of multiplication is division. So 8x divided by 8, whatever I do on one side, here's our invisible wall, we have to do to the right side as well. So I divide the 6 by 8. So 8 over 8 is equal to 1. So 1 times x, we can rewrite it as x, is equal to 6 over 8. We can further simplify this fraction by dividing the numerator and denominator by 2, which is equal to 3, 4. Now let's look at question 4. We have x divided by 6. So it's x divided, division. So the opposite operation of division is multiplication, is equal to 2.5. So that means I'm going to multiply both sides by 6. So I'm going to multiply the left side by 6 and the right side by 6. Because another way to look at this is, and I'll erase this, but is to view it as x over 6 is also equal to 1 over 6 multiplied by x. So to turn 1 over 6 into just 1, to eliminate that coefficient, if I multiply 1 over 6 times, so if I multiply 1 over 6 times 6 over 1, which is the 6, will give me 6 over 6, which is equal to 1. So I'm eliminating out on the left side, but I'm keeping it balanced on the right side by multiplying 2.5 times 6. I'm just going to erase this. So that is equal to x is equal to 6 times 2.5 is 15. So step 5, or question 5. Logan mows lawns for $45. If he earned $630 this week, how many lawns did he mow? So we have, the first question here asks us to find the variable. So we need to figure out what it is that we don't know. So in the question, usually you'll know what you need to figure out, where usually it states something like what is or how many lawns did he mow. So that is our unknown value we're trying to figure out. So our variable x is equal to or represents the number of lawns mowed. There are two other facts in this question. I'm going to change the color. There's for $45 each, and he earned $630. We need to figure out how many did he mow times $45 will give us 630. So the equation becomes $45 times the number of times that he mowed the lawn, which we're trying to figure out, will give us a total of $630. So now we're going to solve this by isolating the x. So to isolate the x, because 45 and x, there's a multiplication there, we're going to divide. So we're going to divide both sides by 45. Therefore, x is equal to 14. The number of lawns that he mowed were 14 to get $630. And then there are practice questions you can complete for one-step equations.